Around 252 million years ago, near the end of the Permian period, Earth looked very different from the planet we know today, because almost all the land was fused together into a single massive supercontinent called Pangaea. And that enormous landmass created huge continental interiors where moisture rarely reached. So vast deserts stretched across the center of the world, yet life was thriving despite the harsh geography, because early reptiles, giant amphibians, and mammal-like synapsids dominated the land, and the oceans were filled with coral reefs, trilobites, ammonites, brachiopods, and fish. And these ecosystems weren't new or fragile either. They had existed and evolved for hundreds of millions of years, surviving multiple earlier extinction events. And if you looked at the fossil record at that moment, nothing suggested the biosphere was about to face the worst collapse in Earth's history. And then, the planet itself began breaking. Because in what is now Siberia, enormous volcanic eruptions started tearing through the crust, and these eruptions eventually formed a gigantic volcanic province now called the Siberian Traps. And the scale was almost unimaginable because lava flows eventually covered more than 2 million square kilometers, an area larger than many modern countries. But the eruptions didn't happen once and stop. They continued for hundreds of thousands of years, releasing enormous volumes of volcanic gases into the atmosphere, especially carbon dioxide, and possibly large amounts of methane released from underground deposits as magma heated buried carbon sources. And those gases trapped heat in the atmosphere, causing global temperatures began rising rapidly, with some estimates suggesting the planet warmed 5 to 10 degrees Celsius, which is a massive shift for a global climate system. And warming doesn't just change the air, it changes the oceans too. Because warmer water holds less dissolved oxygen, and as temperatures climbed, large parts of the oceans began losing the oxygen that marine animals depend on, creating expanding low-oxygen zones, and animals that required stable oxygen levels struggled to survive. The entire seafloor ecosystems began collapsing. Circulation patterns in the oceans starts weakening, and stagnant water layers start forming. In those oxygen-poor environments, bacteria produce hydrogen sulfide gas, which is extremely toxic to most complex life. And some researchers believe this poisonous gas may have even reached the atmosphere in certain regions, potentially damaging both marine and terrestrial ecosystems. And as the oceans deteriorated, the fossil record begins showing the scale of the disaster. Because extinction rates among marine organisms started climbing rapidly, and eventually around 90 to 96% of marine species disappeared, making this the most severe extinction event known in Earth's history. Entire reef ecosystems vanished from the oceans, leaving gaps that would remain empty for millions of years. And one of the most famous victims was the trilobite, a group that had survived on Earth for roughly 270 million years before disappearing completely during this event. Many ammonoid species also vanished suddenly, showing how rapidly marine ecosystems collapsed. But the catastrophe didn't stay in the oceans, because on land ecosystems were also destabilizing, and evidence from fossils shows that around 70% of terrestrial vertebrate species disappeared, and large predators that once dominated Permian landscapes vanish from the record. Plant communities also began collapsing, and in many regions forests disappeared entirely, and fossil soils from this period show clear evidence of massive plant die-offs, with fewer plants holding the ground together. Rainfall began washing enormous amounts of sediment into rivers, which then carried that sediment into the oceans, further disrupting marine environments that were already struggling. And when the disaster finally stops, the world didn't recover immediately, because for millions of years the planet looked strangely empty, and complex reef systems that once filled the oceans simply didn't exist anymore. In some marine environments, microbial mats, simple bacterial communities, began dominating seafloors where complex animals once lived, and food chains became extremely simple, while the ecosystems became fragile and unstable, with only a few types of organisms able to survive the harsh conditions left behind by the extinction. Among those survivors, one animal appears everywhere in the fossil record, because a stocky herbivore called Lestrosaurus suddenly becomes incredibly common in early Triassic deposits. Even fossils suggest that in some ecosystems, this single species made up 80 to 90% of vertebrate individuals, which is almost unheard of in normal ecosystems. And that dominance tells us something important about the world after the extinction, because such extreme abundance means biodiversity was extremely low, and only a handful of adaptable species remained. And those survivors often shared certain traits, because many surviving animals were small and adaptable, and species capable of burrowing underground may have survived environmental extremes more easily, and some organisms appear to have tolerated low-oxygen environments, giving them an advantage in ecosystems where oxygen levels fluctuated. But even after life stabilized, recovery was painfully slow. Because unlike many other extinction events where ecosystems rebound relatively quickly, the aftermath of the Permian extinction lasted 5 to 10 million years, during which ecosystems remained unstable and simplified, and only gradually did new predator species begin appearing during the Triassic period. Slowly, reptile groups diversified to fill ecological niches that had been left empty by the extinction. And during this long recovery, something new quietly began evolving. Because early dinosaurs first appeared during this rebuilding phase of the Triassic world, and reptile groups gradually diversified and spread across land environments that had once been dominated by completely different animals. And over millions of years, biodiversity slowly increased again. New ecosystems eventually formed during the Middle Triassic, and life rebuilt itself step by step from the small number of species, and only much later did dinosaurs rise to global dominance. But that future only happened because a few organisms made it through the worst extinction in Earth's history. Because if those survivors had vanished as well, complex ecosystems might never have returned. And that is why the Permian extinction is often called the moment Earth came closest to losing complex life entirely. If you like more prehistoric content like this, be sure to like and subscribe, and we'll meet again in next video.